Welcome Algebra 2. This video is on the properties of exponents and geometric sequences. The essential question is, what is the relation between exponents and geometric sequences? Let's begin. This video should be a lot of review from Algebra 1. So I'm throwing a lot of stuff out there, but I hope you've seen it before. Here's all the laws or properties of exponents. So I just pause the video right now and write it down. And then we're just going to go through examples of all these. So let's break it down. So zero exponents. So every time you have something to the zero power equals 1. So 4 to the 0 power equals 1. Negative 3 to the 0 equals 1. And 1/5 to the 0 also equals 1. That's it. If you had 0 to the 0, this is actually undefined. So that's one of those special cases. Next one. Negative exponents. So negative exponents. So if you have a something to the negative power, we can rewrite this as just 1 over that something to the positive power. So basically we kind of flip it. If that's a to the negative n over 1, we flip that a to the other side of the fraction, so it becomes 1 over a to the positive n. You flip it to either the numerator or the denominator to make it positive. So for example, 7 to the negative 3 power would be 1 over 7 to the positive 3. And if you expand that out, that'd be 1 over 273, because that's 243, because that is 7 cubed. Next one, 1 over x to the negative 4. So it kind of works in the same way. Instead of it going from the top, the numerator, to the denominator, this x to the negative 4 will come to the top, and it becomes x to the positive 4. So that's negative exponents. Multiplying powers of the same base. So the same base, if you have a to some power times a to a different power, you can just add those exponents up. So for example, 3 squared times 3 to the 1 power, since it's the same base of 3 and 3, that becomes 3 to the 2 plus 1 is 3 cubed, which is 27. Next one, 2 to the 5th times 2 to the negative 4, same base. So 5 minus 4 becomes 2 to the positive 1 power, or just 2. 4, same base, even though there's fractions, you can still add up fractions. 1/3 plus 2/3 is going to be 4 to the 3/3 power, which is the same thing as 4 to the 1 power, or just 4. You're adding those exponents. Now, this one's a little different here. Power of a power, you multiply the exponents. So if you have some number to some power, and then all of that to some power, so there's only one base here. There's only one a, and it's power to a power. You multiply those powers together. So it's kind of, I think of it like distribution. When you distribute something in parentheses, you multiply it by all the terms. You're multiplying it by all those exponents. So for example, 5/4 to all that squared is you're going to multiply these two exponents. 5 to the 4 times 2, which is 5 to the 8th power. M cubed all to the 5th power, you multiply that, so it becomes m to the 3 times 5 power, which is m to the 15th power. A to the 3/2 power, all of that cubed, you're multiplying those powers. So a to the 3/2 times 3, and that's like 3 over 1, that becomes a to the 9/2 power. And I can leave it as a to the 9/2 power. Alright, power of product. So you have a, b, that product right there, a times b, all that to the n power. This n gets distributed to every variable in here, and every number. So it becomes equal to a to the n times b to the n power. So for example, all 3x all to the 4th power, I'm going to distribute that 4 to the x and to the 3. So it becomes 3 to the 4th times x to the 4th. 3 to the 4th power is going to equal 81, and x to the 4th we just leave as x to the 4th. This other example, this is y squared times z to the 1 power. So I'm going to distribute that 3 to both the y and the z. So get y to the 2 times 3, or y to the 6th power, and z to the 1 times 3, or z to the 3rd power. Next one, quotient of powers. So you're dividing them. You have the same base and you're dividing it. You just subtract those exponents. The exponent of the numerator minus the exponent of the denominator. So for example, 2 to the 6 over 2 squared is going to be 2 to the 6 minus 2, which is going to be 2 to the 4th, and 2 to the 4th is going to be 16. Over here, x to the 4th and x to the 7, it'll be x to the 4 minus 7, which is going to be x to the negative 3, and using our negative exponent properties, I can rewrite that as 1 over x to the positive 3. Now, there is another way to do this. You don't have to follow these rules. When I see this x to the 4th over x to the 7th, sometimes I'm going to rewrite that down here. X to the 4th over x to the 7th, I just kind of cancel things that match on the top and bottoms. So we can rewrite these out as 4x is on the bottom, and 7x is, or 4x is on the top, and 7x is on the bottom. What happens is just cancel out matching x's on the top and bottom. So these cancel. Let's do this in brown. These cancel, 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 and cancel. What am I left with? Well, nothing on top, and when there's nothing, just leave a 1. And then 3x is on the bottom, so that's x cubed on the bottom, which is our same answer. So you don't have to follow these formulas if you know other ways to do this. Absolutely not. All right, geometric sequences. So looking at these two examples, you're just looking at the pattern here. What are the next numbers in the pattern? Even just pause the video if you have to. So looking at the pattern 1, 2, 4, 8, 16, you might say, hey, it's doubling every time. So the next number in the pattern, double 16 is 32, and double that would be 64. Looking at this pattern, I go 100, 50, 25, and 25 halves. Well, I'm cutting it half every time. So half of 100 is 50, half that's 25. Half of 25 is 25 halves, or 12.5. Divided again, you get 25 fourths, and then so on. So that's the pattern going on here. And these are geometric sequences. So the official definition of a geometric sequence is the ratio of any term to its preceding term is a constant value. So to say that in simpler terms for you, it's you're always multiplying by the same number or dividing by the same number. It's the same concept. So in this case, for that first example, I was always multiplying times 2. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. So a geometric sequence, you're always multiplying by some number. 16 times 2 was 32. On the bottom, you could say I was multiplying by 1/2, because 100 times 1/2 is 50. 50 times 1/2 is 25, and so on. So you knew 25 times 1/2 following that pattern would be 25 over 4. You could also say that in a very similar fashion, say, well, I just divided by 2 every time, divided by 2. And that's saying the same thing. So it's multiplying or dividing by the same number every time. All right, let's do some examples. Simplify these, pause the video. All right, simplifying here. I'm going to look at these numbers first here. There's a lot going on here, but -4 times -2. So -4 times -2 is going to be -8. And then for the k's, I have k to the -1 power times k to the 4th power. Well, k to the -1 times k to the 4th, you just add those exponents, so it's going to be k to the -4 plus -1 plus 4, which will be k cubed. So I'm going to have -8 k cubed, and that's my answer. This bottom one here, well, I have negative n to the -3. This is like -1 times n to the -3. So 4 divided by -1 will be -4. And then n to the -1 over n to the -3. I'm going to follow the rule for the dividing the exponents. So it's going to be times n to the -1 minus -3. -1 minus -3 is like -1 plus 3. So this comes out to -4 times n squared. And that's my final answer. And of course, there's other ways you could have done that. Try next one. Pause the video. All right, well, the next 3 terms in geometric sequence. So I'm going to say it's geometric. That means you know we're multiplying by something. So you just got to figure out what the first one is, and then you can figure out the pattern. -3 times what is -12? Well, -3 times +4. It's be -12. And -12 times +4 is -48. Times +4 is 192. So -192 times 4, oh boy. 192 times 4, if you're doing that math, you're going to get 8. Carry 6, carry a 3. And it's going to be 7. 768. So it'll be -768. Multiply that times 4. So I'm going to say 768 times 4. And 8 times 4 is going to be 32. Oops, that's going to be a 2 down here. Carry a 3. 6 times 4 is 24. Plus 3 is 27. Carry a 2. And that's going to be 30. So then my next one's going to be -3072. And last one I multiply by 4 again, so 3072. I didn't really use nice numbers here. So 4 times 2 is 8. 4 times 7 is 28. Carry a 2. 4 times 0 is 0. Plus 2 is 2. And it'll be 12. So it'll be -12,288. So my next 3 terms. That's it.